In this video, we're going to be talking about real numbers. All numbers on a number line are real numbers. This includes positive and negative numbers, fractions, decimals, square roots, cube roots, pi, as well as rational and irrational numbers. Some important subsets of real numbers are the natural numbers. These are the numbers that we count with. So the numbers 1, 2, 3, 4, 5, and so on are all natural numbers. Whole numbers are the counting numbers, including 0. So if we add 0 to the counting numbers, so if we add 0 to these numbers up here, then we get the whole numbers. Integers are positive and negative whole numbers and 0. So -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And if I keep going in either direction forever, those are my integers, the positive and negative numbers, including 0. Rational numbers can be written as a fraction. It's a ratio of two numbers. So any number that can be written as a fraction or as a ratio is a rational number. Irrational numbers are non-terminating, that means never ending, non-repeating, numbers that don't repeat, so non-terminating, non-repeating decimals, and radicals that cannot be simplified. A set is a collection of numbers. An element of a set is a number in the set, and the sets are written listing the elements inside of curly braces. Set A is said to be a subset of set B if all of the elements in set A are present in set B. So here we have our real numbers, and all of these subsets are real numbers. Rational numbers are a subset of real numbers. Integers are subsets of both rational numbers and real numbers. Whole numbers are a subset of integers, rational numbers, and real numbers. And the natural numbers are a subset of whole numbers, integers, rational numbers, and real numbers. Irrational numbers are a subset of real numbers, but they are not a subset of any of these. So for example, natural numbers are a subset of whole numbers because all of the natural numbers are also whole numbers. Down here it says list all subsets of real numbers from the list below that each number belongs to. So we are choosing between real numbers, irrational numbers, rational numbers, integers, and whole numbers. So we want to list all the different subsets that 8 is. Well, 8 is a real number. 8 is not an irrational number. It is a rational number because I could write 8 as a fraction. It is an integer, and it is a whole number. And I'm just getting this just by looking at these definitions that we talked about up here. So because I know that 8 is a number on the number line, that makes it a real number. It's a rational number because you can write 8 as a fraction. I could call it 8 over 1. It's an integer, and it's a whole number. 10 divided by 3. That is a real number. All of the numbers that you can think of are all real numbers. You haven't learned about any other types of numbers yet that are not real numbers. In Algebra 2, you're going to learn about numbers called complex numbers, which include imaginary numbers. It is also a rational number because 10 over 3 is a fraction. It's not an integer because integers can't be fractions. And it's not a whole number because a whole number can't be a fraction. On C, I have the square root of 2. Now, if you're not sure about the square root of 2, you could pull out a calculator. Here I have pulled out Desmos, and I could type in the square root of 2 in my calculator. And here I can see that I have this decimal here. And this is an irrational number. So actually, the square root of 2 is a pretty famous irrational number. Another really famous irrational number is the number pi. And so this is a real number, but it's also an irrational number. It's not rational because I can't write the square root of 2 as a fraction. And it's not an integer, and it's not a whole number, and it's not a natural number. These three things right here, integers, whole numbers, and natural numbers, are all non-decimals and non-fractions. Negative 29 is a real number. It is a rational number because you could write that as a fraction. And it is an integer. It's not a whole number because whole numbers are not negative, and it's not a natural number. So those are all the different subsets of those numbers there. For example 2, it says order the numbers shown from least to greatest. Well, I don't really know what these numbers are, so what I'm going to do is I'm going to type each of these numbers into my calculator and get a decimal equivalent. So the first one that I'm going to look at is the square root of 80 divided by 3. So in my calculator, I'm going to do the square root of 80 divided by 3. And I get 5.16. And then I'm going to do 53 divided by 12 in my calculator. Oops. And I get 4.42 if I round that to the nearest hundredth. And then I'm going to do the square root of 6 in my calculator. And I get 2.45. So now what I'm going to do is I'm going to look at the decimal equivalents to help me put these in order from least to greatest. The smallest out of all these is 2.45. So the square root of 6 is the smallest number. And then out of 5.16 and 4.42, this one is smaller. And so I'll have 53 over 12 as my second one, which means the square root of 80 divided by 3 is the largest out of those three numbers. And then down here we have some definitions that we're going to know about. So the sum. In math, when we're talking about sums, we're talking about adding. So the sum of a rational number and a irrational number is rational, always. The sum, so again, we're talking about addition, of a rational number and an irrational number will be irrational. The sum of an irrational number and an irrational number could be either rational or irrational depending on the problem. The product in math, when we're talking about a product, we're talking about multiplication. So the product of a rational number and an irrational number will be rational. The product of a rational number and an irrational number could be either irrational or rational depending on the problem. And the product of an irrational number and an irrational number could be either rational or irrational depending on the problem. So let's try a couple of examples here. It says determine if the following represent rational or irrational numbers. So on A, I have the square root of 9 plus the square root of 4. Well, the square root of 9 is 3, and the square root of 4 is 2. 3 plus 2 is 5. 5 is a rational number. If you weren't sure, you could plug this into Desmos or a calculator, and you could try it for yourself. So the square root of 9 plus the square root of 4 is 5. So 5 is a rational number. I can write 5 as a fraction. For part B, I have 1/2 plus 1/2. Well, 1/2 plus 1/2 is 1. 1 is a rational number. Again, if you weren't sure, you could plug it into your calculator and see what you get. For part C, I have the square root of 8 times the square root of 3. For this one, I am going to plug this into my calculator. So I'm doing the square root of 8 times the square root of 3. And I'm getting a decimal here. If you could also multiply these together, you can get the square root of 24. And I'll show you how that's the same here. If I multiply what's underneath the radicals together, you'll see that you get the same thing. So the square root of 84, the square root of 24 cannot be simplified. Here, this decimal does go on forever. I can't simplify it any further than this. This is an irrational number. For example D, I have 3/4 times the square root of 2. And if I try that, I would have 3, let me do this. Let me get my fraction, 3/4 times the square root of 2. And this is also going to be an irrational number. If you multiply this together, you'll get 3 square roots of 2 over 4. That also doesn't reduce, as we saw in the calculator. It is a non-terminating, non-repeating decimal. If you're like, hey, wait, but this ends, Desmos only goes over to so many decimal places. These numbers actually do continue to go on forever. So because they are non-terminating, non-repeating decimals, they are irrational.